Hi, we're back. Going to do a quick video. This time we have our fake ROM board. That's the top one of the boards here, and our fake ROM programmer. So like a lot of other people, what we do is we have a chunk of code in Flash, and on boot it copies it into RAM, and then the code runs from there. But we've done a few things that are a little bit different. So what I'm going to show you first is running the code. So we have to do this slightly awkwardly because the clock board isn't yet in. So when I release, what you'll see is the fake ROM board copying from the flash to the RAM, which is that, it's done, it's copied it. And then as soon as I release the run, you'll see we have the test Knight Rider code. Pretty simple test, but it proves that we're booting. One of the nice things is we have 10 different bits of code that we can run. So that was program 1. What I'm now going to do is reprogram program 1 with our test all code. So I go over here on my laptop, and John's written a little Python script that does this for us. So I will load this up, and what you will see is this board here. Now this board John's very cleverly designed. This is also a discrete TTL processor that handles the interaction from the USB, which appears as a serial port, and does all the interacting with the RAM and all the rest of the bits and pieces. It's a very specific instruction set, really only designed for handling USB comms. So if I'm going to upload the code, and you'll see it do stuff. There we go.
I should clarify that chip there is not a TTL chip. That is a USB to parallel FTDI chip, but it just outputs a standard parallel signal at TTL levels, and then everything else just talks parallel to it.
Yeah.
So in the oldie days, you could have pretty much taken that off and put a parallel port connector on there and had it, but computers nowadays don't have parallel ports.
Yeah. So that's now done. So what I'm going to now do is I'm going to do a reset and pause. So what this will now do is that's copying that new code into the RAM, and that's done. I'm going to release, and you'll see it runs our test all code, which is really nice. So it's testing the registers, and there you go, they've passed, testing the rotates and doing all the other bits and pieces. This is really cool for us because this now lets us have 10 bits of code in there. So we can have different programs. I've still got the Knight Rider in there. So when I go to program 0, we're still running the test code until I do a reset. And once I let go of the reset, copies it, and off we go. And we're back to the Knight Rider. So this is a really handy way of us being able to have lots of programs that we can demonstrate some of the really cool features that we have. Let's copy that one back in. There we go. And now we're back off with our test all code. So yeah, it's going, it's working really well. We've got a clock board to redo because we've added some functionality in, like being able to switch speeds and being able to pause. So that'll be the next thing that we tackle. But yeah, this is going really well. We're super chuffed. We've now got a programmer, and things are going really well. So one unexpected and rather pleasant thing that we've just discovered is, if you remember from a previous video, we had some glitches in the display here and the display here when we were running at 4 MIPS. We now don't have them, which is really nice. The characters are fine, the dots here are fine, so that's a rather pleasant surprise to see that, yeah, everything's behaving as it should. So if I do that, I go with that, and then run. Yeah, no glitches. This is really good. So we can run the display in the memory at 4 MIPS. So yeah, that's really cool.